This is on the third page in that guided practice packet, and we're going to go over number 2 together. So we can see that it is a cubic function. If we want to graph its inverse, we don't have any table to go off of, so we are going to make a table for our original function, f of x, using 3 points. You can use more, but I wouldn't use less. So identifying the coordinates of these points, backwards 3, down 1, -3, -1. Backwards 2, up none, -2, 0. Backwards 1, up 1, -1, 1. I want you to find the inverse table and see if you can graph it. This is one where I think using that line of reflection is very helpful for figuring out what the shape of it looks like. Go. Where does that line of reflection start, and what is the slope of it? How do we do? That's what your table should look like. That is what your line of reflection looks like. So now we have to try to figure out how to do the shape of this. If I were you, I would turn it so that your line of reflection is straight up and down, because I think it's a little bit easier to mirror this way. So cubics are a little bit challenging to do the shape of anyway, so doing the inverse of a cubic is also kind of challenging. You could also reflect other points, but none of these other ones look like they're going to be exact, so I just kind of rough it on the shape. So from this point, it looks like we start curving outward from our line of reflection. What does it look like we're doing between these 2 points? We're dipping in towards the line here, so we're going to dip in towards the line there. And then we curve down, and then we head this way. Is it perfect? No, but it is close enough. Oh, and you know what? It's definitely not perfect because, no, that's right. That's right. Let me do this way. Ooh. That's about as complicated a problem as we're going to see as the cubic ones, which I think are kind of challenging, but that is what your graph should look like. And if we check those points, this goes over here, this goes over here, and this goes over there. So we can see that each of those points has been reflected in equal distance. All right, folks. Any questions on that one? Number 4, from the top. First, graph the original function, and what are we going to need to find first? We're going to have to find the parent table and then apply transformations to figure out what this transformed quadratic looks like. So a few minutes to try the first part of this one of graphing that original function. Go. All right, folks, how did we do with our original function? Parent table looks like this. That -4 on the outside moves us down 4, so we're going to subtract 4 from each of the y values. So that is my original function. So now, how are we going to find the inverse function to graph it? Switcheroo the tables. Switch all the x values and all the y values around. So -1, -3 becomes -3, -1. 0, -4 becomes -4, 0. 1, -3 becomes -3, 1. So, swooshing through those points. There's our inverse. So I wanted to go over this one because it's kind of messy. We've got those quadratics and, well, we actually know that that's a square root function. We've got them overlapping each other. And this is another good place where it's good to do the check with the line of reflection. So this point was reflected over here, this point over here, and that point over there. So even though it's messy, our graph checks out. Now, I want you to find the inverse equation. And folks, you can go ahead and just show your work down here below the graph. So see if you can find that inverse equation. Be careful about those little details. There's two tricky things to the equation for this one. The first is since we have to square root, you have to include the plus or minus in front of your square root. But the second tricky thing is this. Did you remember to replace y with that inverse of f of x label? Because that's what we're going to be looking for on the test. And even though we don't have to graph it from this, it's still a nice idea to use your transformations and see if that makes sense. So that +4 on the inside would be moving us left 4. So left 4, there's my vertex. The plus is what swooshes the square root up, and the negative is what swooshes that part of the square root down. So folks, page 5 is due tonight. But I would try to get all the way through 29 and 30 as well. Would you guys like to go outside to work? No. Okay, we're going to have to take a vote. Raise your hand if you want to go outside. I don't think we got majority, folks. So we're going to go ahead and stay in here. Maybe when it gets a little more polished up, maybe we can go outside. So we...
Why do we want to go outside when it gets cold?
When it gets cooler, not colder.
No.
For those who wanted to go outside, we'll let some of the sunlight in.
It's 81 degrees outside. It's balmy. It's just I don't want to write on the side.
Yeah, you guys. So page 5, do tonight.
Get her done. Get her done.